Hi everyone. I decided to record a quick demo video on the discussion that I recently posted. It's due August 12th. It's on hypothesis testing, which is basically based on Chapter 10 material. So I've gone ahead and made it a page in this module on Chapter 7 through 10, which is corresponding to Test 3. So here I'm in the Canvas course, I'm looking at modules, and I'm talking about the last item in the Test 3 module. You would also be able to find this on the due date in the Canvas calendar, and since it's a Canvas discussion, it would also be presented in the Canvas discussions section. Anyway, I'll just access it from here, and it should pop up with some instructions and what to do. Your instructions are here, and some deadlines are here, and basically what you need to do is go through the steps that are described in this PDF. So if you, I'll show it to you in a second, but if you click on this PDF, it should download a file and give you some instructions. And this is a link to an applet that is built in StatCrunch. And then that PDF file asks you some questions which you should answer as a response here. So you can just type number 1, give your answer, number 2, give your answer, and then the third step is to do some responses to at least one classmate. Hopefully you respond to more than that. Anyway, if you click on the PDF, this is what it looks like, and it's an activity on the logic of hypothesis testing. So the scenario is that a politician wants to know if a majority of her constituents are in favor of a certain policy. So we're imagining that a polling firm were to obtain a random sample of 500 registered voters in the district and ask whether or not they're in favor. And what we're going to do is explore the logic of a hypothesis test using this simulation of coin tosses. So here's the link. I've also posted it back in the discussion. This link opens the applet that allows you to do the simulation. Now it's not obvious what's going on here, but the applet is already pre-coded as a coin toss, 50-50. And so since this PDF is setting up a hypothesis test with the null hypothesis that p equals 0.5, right? Because what she wants to know is whether or not more than 50% of the constituents are in favor of a policy. So the null hypothesis is always the boundary of what you're trying to determine whether or not your sample provides evidence for. And so that's why a coin toss is reasonable in this scenario, because theoretically you should have a 50-50 chance of heads or tails. And so this applet is already hard-coded with heads or tails. And so it's also hard-coded with 500 coin tosses. So if I click one run of the simulation, what that's done is flipped a coin 500 times, and what it did is simulate that process, and it said there were 268 of those 500 flips came up heads, 232 of those 500 flips came up tails, and what they're putting down here on the graph is that the number of heads, which was 268, was here. So this bar is at a height of 1. This vertical axis is a frequency axis, so that's frequency 1. This thing represents exactly one simulation, one run of this simulation. The simulation assumes a 50-50 chance of heads. It returns the number of heads in 500 tosses. And so back on this PDF, when they ask you to simulate obtaining a simple random sample of 500 voters, assuming that p equals 0.5 exactly one time, that's what I just did in here. There was one simulation of 500 runs, 500 coin tosses, 268 of them came up heads. I'm going to jump ahead in the PDF a bit, but if you click on 1,000 runs, what it did here is generate, and I can click on any one of these. If I click on one, the 911th simulation of 500 coin tosses resulted in 258 heads and 242 tails. So what this column is each row of this column is 500 coin tosses. And what the simulation returns is how many of those are heads. If you click on one, notice the green arrow here is representative of that 973rd simulation of 500 coin tosses. And it's on at 244, which is the number of heads, and that's what the horizontal axis says. So what this thing up here is for is to allow you to define certain parameters here. So if I do like 250, what it's going to do is shade all of the simulations that had greater than or equal to 250 heads. And so this way you can use a computer to flip lots and lots and lots and lots of coins in order to give you some intuition about what's going on here. So this is an exploratory exercise. There are 9 questions in this. It asks you to go through it, and it asks you to really explore the logic of a hypothesis test. Now the deadline is the 12th because I didn't want to add undue pressure on the test. However, I do think that going through this is helpful in understanding some of the concepts of the test, and some of the hardest concepts I think in this test live in chapter 10, which is really the logic of hypothesis testing. So I think it's a good idea to go through this well before the test, so sometime in the next few days. Of course, if you have any questions, please post them to Pronto. I can make additional videos, but please dive into this and see what you come up with. And also, please be reading your classmates' posts and respond to those. Okay, let me know if you have any questions. Take care.